All right, let's talk about the review for a second. The review that is on Blackboard is the review from the department. Very comprehensive, very well done, and it covers everything. And the answers are on there. So there are a couple of ways that I could recommend that you study for this test. And one of them is go through, look at the questions, and check off each one you really know how to do. And just leave it to review it when you, or try one and see if you got it right, that sort of thing. If you don't know how to do it at all, go back and watch the videos, look at your notes, do whatever, and don't wait and do that on Monday night, because Tuesday is when you've got to be ready for that test. It's all split up into sections, so you know exactly where to go and get the information, and again, the answers are all there for you. What I like to do in review is something a little bit different. I like to look at the big picture. So I am going to do a summary. What exactly did we talk about? And how are we going to clarify anything that we have a problem on? So this is a concept review or a review summary or something of that nature. I don't care what you call it. But let's just briefly go over things. The first part that we talked about was, actually we did the reading, but that all leads into the next. Being able to read a problem and look for detail versus big picture is key to success in all the rest of it. But the next thing that we did was the problem solving. And we talked about that. We looked at systematic counting and listing, the multiplication principle, and guess and check. All of them very valid. So the systematic counting method, it's really two ways that we can do this. If we look at the counting, then we are looking at a tree. And the example that we used was a coin toss. So we knew with a coin toss we could either get a head or a tail. Then for each of these we could either get a head or a tail, a head or a tail. The listing then comes if I list all the possible combinations. So if I go head, 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 tail, tail, head, or tail, tail. This gives me the same information. So you can get the listing from the tree, and that's a really good way to do it. The next thing we looked at was the multiplication principle. And what the multiplication principle states is that you can take the number of options for choice 1 times the number of options for choice 2, and that just keeps going on, and that will give you the total options. So for example, here with my first coin toss, I have 2 options. For my second coin toss, I have 2 options, so 2 times 2 is 4, which is the same thing. But let's say, for example, we did one with a clothing. If you have 4 pairs of pants and 5 pairs of shoes and 10 shirts, multiply them together, 4 times 5 times 10, and you end up with 200 outfits. Wow, that's a bunch. Okay, guess and check. Very good strategy, sometimes not always very efficient, but you need to start with make a guess. And you could start out by making it a reasonable guess. We talked about this before. If you're looking for 3 things, maybe divide it by 3 and start there and see if you need to go up or down. And then you're going to test it. And that you might want to make a table. I find that very helpful. After you make your initial guess, you are going to then adjust up or down based on the result. All right, so this was the kind of problem when we had one with paying the bill, like the electric bill in December, January, or December, July, and August, and I don't remember what the other example was. Okay, so that was 1.5 problem solving. Boy, it seems like a long time ago that we did that. All right, the next one is about logical fallacies. Now on here, I'm not going to go through this with you, and there's a reason for this. You have in your notes, you have so in notes, you have the definitions and you have the links to videos so you can do examples. Now the reason I put this on here and left it blank for you is this is important for you to put in your own words. What is a definition that makes sense to you? Okay. How are you going to know if something is a limited choice or if it is a false cause? What is going to be meaningful for you? Can you give an example? And create examples. Can you give me an example, something that is not necessarily on the video, but you know, that sort of thing? Can you go both ways? Can you, if you're given a situation, can you identify it? If you're given a type of fallacy, can you come up with an example? So go both ways on that. All right. It's not a matter of memorization. It's a matter of recognition. What do each of these mean, and can you utilize them? Okay, then we're going to go to the next page. And this talks about the next thing that we went over, which were sets and Venn diagrams. Okay. So let's see how we're going to get started on this. Here's how I think I'll do this. We know the universe is the total of all regions. So let's see what we're going to do with this. I'm just going to call this one A. So this would be, on my two-way table, this would be A, and then this would be not A. Okay. So, and we'll call this one B, and this would be not B. Whatever it is. Then, of course, this is the total. And this box here is the universe. This is how many are in the universe, because you're adding everything up, whether it's in a circle or not in a circle. So let's go back and do this the way we did it in our notes. I'm not going to put the R1, R2, and R3 because those are arbitrary. And so you can see those. This in the center here, this is A and B. Okay. This part here is A, but not B. this part over here is B but not A. And then finally, everything out here is not in either one of the circles. So this is going to be our A and not A. Okay. Then when you add these two together, they equal this. Add these two together, they equal this. Going across, this plus this is equal to this. This plus this is equal to here. So going down or going across becomes this total. Okay. Let's now talk about the difference between the inclusive OR and the exclusive OR. The inclusive OR, again, if I call this A and this B, is A or B or both. Which means I can color in this whole thing. Okay, still can't stay in the lines. Okay. The exclusive OR means A or B, but not both. So again, if I call this A and this B, the overlap would have to be excluded. So it would just have to be this part here. All right, now just to give you a general idea of the pictures of these, I didn't do anything fancy. The overlapping sets are what you've seen above. They overlap. Disjoint sets don't touch. They have nothing in common. And a subset is when one set is entirely inside the other. All right, I'm going to switch videos.